we will solve today's LeetCode problem. So this is LeetCode medium, replace words. Let's see what the question is. So here we have given in English we have a concept called root, which can be followed by some other word to form another long word. Let's call the word derivative. For example, when the root help is followed by the word full, we can form a derivative helpful. Okay, so uh, here the root is help, and when we add the full with this root it becomes helpful. Okay, so we have given a dictionary consisting of many roots. Okay, and a sentences consisting of words separated by spaces. Replace all the derivative in the sentence with the root forming it. Okay, and if a derivative can be replaced by more than one root. Okay, first understand this line, that given a dictionary consisting of many roots, this dictionary is consisting of many roots and the sentences consisting of words separated by spaces. Okay, replaces all the derivatives in the sentence. Okay, the words which are written in this sentence are the derivatives, and which should be replaced with the root in the dictionary which was given, right? And if a derivative can be replaced by more than one root, replace it with the root that has the shortest length. Okay, and return the sentence after the replacement. So the question is basically asking that we just need to replace the words of sentences, the words of sentences with the string or root given in dictionary arrays, array of dictionary array, right? Dictionary array, dictionary array of strings, right? So, and if there are more than one root present in this dictionary which can be replaced the word of this sentence, then we will choose the shortest length of this root, right? If you see in this example dictionaries and the sentences, if we see the example in this the any string is not present in dictionary, so this the will be not replaced by any of this, so we will store this the, right? Again, the cattle, c is available, no. Ca is available, no. Cat is available, yes. Cat is available. It means the cat, the in this cattle, the cat is a root which is present in this dictionary, so we will remove this tle, which is a derivative in this word. So we will just replace this cattle with cat and insert that, right? Again, was, was, nothing is available in dictionary, so we will simply put this was. Rattled, rat is available, and nothing is available less than this length, so we will replace this with rat simply, right? Again, by, no, nothing is available, we will simply write this by the. Again, battery, for battery bat is available, right? Bat is available, so we will replace this battery with bat, right? This is for, this is how we will replace the word by its root if it is present, right? So simply, this is just a statement. You just need to replace the prefix of any word if it is present in the dictionary. You just need to replace with that, right? What does it mean? That if derivative can be replaced by more than one root, suppose there will be present ca, right? Suppose there will be present ca here, so this ca and cat both are present in here, so the word which has the shortest length should be replaced, so the cattle will be replaced with ca instead of cat, right? That's what the meaning of this line. If a derivative replaced by more than one root, replace it with root that has the shortest length. This is the meaning of this line, right? Okay, so basically what we are doing, what we are what the question is asking, that what the question is asking to simply move in this sentence. We will simply move in this sentence, and if for any word any prefix is available in the dictionary, replace with it, right? Simply, right? Okay, so it means i need to I need to in whole sentence iterate in whole sentence, and in each word of in each word present in the sentence, right? Present in sentence, right? I need to iterate in each word present in sentence and check for each word, check for each prefix for each word that present which is present in dictionary, right? That's I need to check. And if it is present, and if it is present, I will just I will just if it is present, I will just replace it. Will just replace it. Okay. Okay. So for iteration part, we know that how we will iterate. I will just start iterating in this sentence, right? But how will we check that whether the current word prefix is available or not? So for checking, what we can do, we can simply go through all the dictionaries words and check. Right? But that will be not an optimal approach, of course, right? Because if we see constants, dictionary's length constants is 1000, and for each word is 100, so that would be 10 to the power 5. And for each word, the sentence is can be 1000, so 10 to the power 5 plus 10 to the power 3 10 to the power 8, which is very maximum, right? So we can't check each and every. So what we can do, so there is a famous proverb: if you don't hit anything, you don't hit anything, just think of a hash map. Just think of a hash map, right? Just think of a hash map. So what we will do, we will simply store all the words of dictionaries in hash map. So what we will do, we will store all the all the words of all the strings of dictionary and hash map, right? Or hash table, right? And what we will do, this is how we will check. We will move in word, and if the word is present in hash table, it means I can replace that word with that table. So what I will do, I will just and okay, if you see here, this sentence is a string. The sentence is a string. So what I will do, whenever the space is coming and it is separated by an space, so whenever a space is coming, it means I got a word. After this the space has come, it means I got a word simply. So while doing that, while inserting the th, so I will also check dynamically that whether this th is present in my dictionaries or not. And if it is present, I will just replace with that number. Why I'm doing that, how and that will be handle this derivative replaced by more than one root, because I'm starting from lowest part now. If my if I starting part if the starting part of the prefix of a string, if the starting part of a string is available in my dictionary, then I can replace with that. Then I can simply replace. Then I can simply replace with that, because that would be minimum length with that. Because that would be minimum length. It would be the minimum length of root, right? That would be the minimum length of root, right? So and we need to replace it by the shortest length. If so, we will whenever the first time we get any of the root in dictionaries, we will just replace it, right? We will just replace it. So and how the word will be formed, so whenever I get a space after the word, it means that after us after a character, it means I got a word, right? I got a word. So this is just an implementation now, because the approach is clear that we will use a map to store all the words of dictionaries, and we will move in the sentences to check whether whether the individual prefix of the string of the word of this sentence is present in this or not. If it is, then I will just simply replace it. If it is not, I will just put this in my answer, right? That's only the approach. That's only the implementation purpose. Let's try to see and that try to implement that, right? So the first thing is that I need to store all the strings of this dictionaries in map. Let's try to it's store it simple. So for it dictionaries, so let's just uh, make this a small, right? mp of it plus I've just stored all the strings present in dictionaries in my hash map, hash table of course. So now what I will do, I will move in this, I will move in this string, right? I will move this in a string. So for moving, I will just iterate in a string. So the string, the sentence size is, and now what I will do, I need to form a word. I need to form a word, and how will I got a word? I need to iterate till I don't get in a space between this word, right? So what I will do, I will move in this sentence till I not get any space between them. If I get a space, it means I got definitely got a word. So before that, what I will do, I will add the character in this word, right? And also I need to check that whether this word is exist in my count in this my hash table or not, because I need to replace if it is present in my dictionary array, right? So if it is present, if it is present, also I need to return a string answer. So I will use a string answer, right? So if it is present, I will just replace this word with that word. I will just replace this word that with that word. So I will just put the word in my answer, right? I will just put the word in my answer. Otherwise, I will just increment it. But here are the few edge cases which are left. The first edge case is, what if the string I is out of bound? So I need to check that, right? I need to check that if it is, it should not be out of bound. The second case, the second case, how will I know that the because I need to replace it by one time only. The first time when we simply got, because that would be the minimum shortest length. After that, I don't need to insert again, right? So for that, I will make a check function, a check variable, a check bool function or variable, anything you want to call, and I will just check that whether this check is available or not. If it is check is not, if I didn't get any first time the word, I will insert it. Otherwise, if the check is zero, it means I have definitely got a word which I have replaced already, right? So I will not insert it in my answer, right? After that, I need to also check one thing, that whether I have got a word in my root or not. In case of this, the, if the, when we are moving for the, then I have not got any of the word present in my dictionary for the, right? So this check will be never be zero. So if check is never be zero, it means I need to insert that word in my answer, right? I need to insert that word in my answer, because that check, that word will never be that word is never replaced by any of the word in the dictionaries. So this is how we done implementation by implement, and then thinking of every edge cases. The first edge case is that I need to check whether I is less than an or not. The second case is that whether I need to check that the answer should be applicable to only the first time. Otherwise, I don't. Next time I will don't insert it. The third time is that if the word is not present in that, so I need to insert it also, right? So this is how we will solve this problem. Okay, one thing is also left, that the sentences which we need to return is separated by space. If you see here, it is separated by space, right? So I need to add space whenever I insert any of the word in my answer, in my answer. So I need to add a space, right? I need to add a space, right? But when we are returning the answer, when we return the answer, I will not return a whole answer. Why? Because if you see, if I if I started uh, if I started putting the word in my answer, suppose the cat, the space, then cat, then space, then was, then space rat, then space by, the space bat, and then also an extra space would be there at last, this extra space. So this extra space we don't need to send. So what I will do, I will just send answer dot substr 0 dot size minus 1. What would be the size? Size will be the answer dot size, right? This will be the size, right? Why I'm sending like this? Because after insertion in this answer there would be an extra space which is what is left, which we don't need to send, right? So this is how we will solve the question, implement this question. So let's try to run this. So yeah, let's try to run this. Okay, compilation error. Let's see any other compilation error. I don't think so. Let's run this. Yeah, we have passed the sample case. Let's try to submit it now. We have successfully passed all the cases. So now what will the time and the space complexity, right? Okay, pause the video and think of on your own that what would be the time complexity, right? So now I will tell you that what the time complexity would be. So here we have taken unordered map for inserting the dictionaries string. So that would be O of M, O of N for dictionaries. So O of M. Also the string which is the string length would be cat, bat, rat. So uh, that can be taken as a W, right? That can be taken as W. For W would be the average length, or you can take average length of the word, right? That would be the average length of word. What would be the M? M would be the total number of words in dictionary, right? Okay. Plus, what would be the time complexity again? So I am iterating in whole sentences. So that would be O of N for sure. O of N for sure. Let's make it capital. O of N for sure. And for each word, when we are forming, I am checking for the word is present in my count or not. That would be O of 1 only. That would be O of 1 only for checking, because hash table takes O of 1, right? Hash table take O of 1 only. So that would be O of 1. So this would be O of N into O of 1 only. And after that, for each answer, I need to take answer dot sub str, right? For each answer, I'm taking answer dot sub str, which takes O of N, of O of N, because this sub str time complexity is O of N. So again, I am taking O of N for that. So that would be again O of. So if you see overall time complexity, if you see overall time complexity, O of N. So if you take overall time complexity, this M into W would be, the M is the total number of words in dictionaries, that can be 1000. W is the average length of the word, which would be, of course, less than 100, not definitely 100, that would be less than 100, of course. O of N, and sentence length is 10 per 6, right? So if you take the worst case for dictionary length, so 10 per 3 and 10 per 2 would be 10 per 5, and this is 10 per 6. So ultimately, you see that it will be O of N ultimately, right? The over time complexity would be O of N, right? And now, what would be the space complexity? The space complexity would be, the space complexity would be, I have taken unordered map, right? So that will store all the words with its length string. So that would be again O of M into W, O of M into W. Now I am taking an extra word which in the for each n word. So if you can take that, or you can leave it, there's no problem, because overall time complexity would be not affect so much. So that would be Okay, and if you see this answer, I'm also taking an answer for returning answer this. So you can take it or you can not take it, it's upon you, because for returning we don't usually take, but if you want to take, you can take. That will be again O of n. So over time complexity, over space complexity would be O of n, right? So this is how we solve the problems, right? This is how we will solve the problems.